Now, vectors is something that always comes up on every exam paper. When we talk about vectors, there are two main qualities to any vector: the magnitude of it, or the length, and the direction in which the vector travels. So, if we take a look at this slide now, you'll see two different vectors, and hopefully you can see the difference between magnitude and direction. If we have two vectors, A and B, you can see here that these vectors aren't equal because they have a different direction indicated by the arrow on the line, and they also have a different magnitude, and that's indicated by the length of the line. Now, when it comes to working out the magnitude of a vector, well, the magnitude of a vector A is given by just A on its own, or A with the two symbols either side of it, and is calculated as follows. The magnitude of a vector, xy, is given by the square root of x squared plus y squared. So if, for example, we wish to find the magnitude of the vector 5, 3, well, the vector 5, 3 takes us 5 across and then 3 up. So if we were to draw those two vectors together, you'd see we'd end up creating a right-angled triangle. And then our knowledge of Pythagoras means we can work out the distance between that start point and end point using Pythagoras' theorem. So we would do the square root of 5 squared plus 3 squared, which gives us an answer of the square root of 34. And we can leave it like that unless it asks us to specify it in any greater detail. Essentially, we use Pythagoras to calculate the magnitude of a vector, and it is the sum of the two vectors squared and then square rooted to get your final answer. So let's calculate the magnitude of a couple of different column vectors. The first one we'll have a look at is 3, 4. Now remember, essentially we're using Pythagoras' theorem to help us calculate the magnitude of these vectors. So we're going to square the two numbers in the vector, add them together and square root to get our answer. So the magnitude of this vector here will be the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, so that gives me a total of 25. So my magnitude is the square root of 25, which gives us an answer of 5. Let's have a look at another one, this time with a negative number in there. Let's work out the magnitude of minus 2, 6. Same process again, we're going to square them, add them and square root. So I'm going to calculate the square root of minus 2 squared plus 6 squared. Minus 2 squared gives us an answer of 4, and remember it's positive 4. 6 squared gives us an answer of 36, so our answer here would be the square root of 40. Now you can leave the magnitude like that unless they ask you to specify it in any other form. Finally, let's have a look at the vector 12, 5. Same method as before, we're going to square root 12 squared, add 5 squared. 12 squared is 144, 5 squared, 25, so that gives us the square root of 169, which gives us a whole number answer this time, so we write our final magnitude as 13.